Hello and welcome to the BMC Quick Course Series. My name is Bob Albrecht and I am a BMC IMS software consultant. In this session, I'll introduce you to Pointer Checker Plus, a tool that validates DL1 structural elements, collects reports and monitors statistics, provides an interactive way to browse and edit segments and blocks, and more. With Pointer Checker Plus, you can validate databases at the same time you image copy or recover them, saving significant time and resources. It assures you that the image copy can be used to recover the database, and it alerts you to broken database pointers as soon as possible when they are easier to fix. Let's take a look. You can use hash checking or full checking to validate the DL1 physical and logical pointers of a database and its related databases. The statistics and monitoring features deal with the space usage and database statistics, including the capturing and reporting of statistics, database threshold monitoring, space threshold and volume monitoring, and statistics history management. The analysis and repair features, database SAP Utility and the DL1 block dump utility, help you diagnose and fix database structural problems. Special purpose utilities include the HD sort utility, the HTM Randomizer Analysis utility, and the Data Restructured utility. The hash checking technique can identify that pointer errors exist in the database, but it is not able to identify the exact pointers in error. Because it takes very little time and few resources to execute, you can use the hash checking technique often. You can execute it as a standalone utility or run it concurrently with another utility, including BMC Image Copy Plus or Recovery Plus. When you run hash checking with another utility, the database is read only once, saving time and resources. The full checking technique identifies the exact pointers in error. Because full checking takes longer to run than hash checking, we recommend that you use full checking only when hash checking discovers an error or when a pointer-related append occurs. When you validate pointers using hash or full checking, Pointer Checker Plus collects database statistics, including the number and average sizes of the segments, the number and average sizes of the database records, and the use of free space. Pointer Checker Plus can capture space usage information without validating pointers. It also collects information from the VTOC or VSAM catalog about space usage, including allocated extents, used extents, and VSAM control area and control interval splits. Pointer Checker Plus prints these statistics in formatted reports. It can save the statistics in a specialized dataset called the PDX, from which you can view and print reports or extract the statistics for analysis. You can compare statistics from two executions and identify trends. Pointer Checker Plus maintains a history of selected statistics that you can use for long-term trend analysis. Pointer Checker Plus monitors significant database statistics and space usage through the use of thresholds. A threshold consists of a base and a positive and/or negative deviation. You can set up a deviation as a percentage of the base value, as an amount, or as a ratio of the current value to the total value. If the deviation reaches the threshold, Pointer Checker Plus flags an exception and notifies you of the condition. Volume monitoring determines whether each volume has enough space to accommodate growth of the data sets to their space thresholds. If the volume does not have enough free space available, Pointer Checker Plus notifies you of the exception condition. Analysis and repair features help you diagnose and fix database structural problems. The database SAP Utility is an ISPF application that accesses and traverses DL1 databases and interactively displays, changes, and verifies segments and blocks. It accesses both the prefix and the data portions of database segments, and it identifies and displays the DL1 elements in blocks. The database app utility provides the ideal environment for directly repairing pointers because it eliminates the manual labor involved in determining block format, chasing pointers, zapping them, and ensuring that the zaps are correct. Use the DL1 block dump utility to get formatted information on the blocks in the database dataset. It prints database blocks in DL1 format, extended DL1 format, or OSVS dump format. It supports addressing by relative byte address, or RBA, relative record number, or RRN, or key, depending on the database type. The HD sort utility sorts an HD unload dataset using either the root's key value or the HTM randomizer's block number and root anchor point. It lets you convert an HTM, HIDAM, or HISAM database from one database organization to another. Using this utility after you change the randomizer or database organization allows you to reload the database more efficiently. The HTM Randomizer Analysis utility analyzes the effectiveness of the HTM randomizing parameters defined for a database and the effect of changes to those parameters. It handles the randomizer module, number of wraps per block, maximum relative block number, database block size or CI size, length of the root segment's key field, free space percentage factor, database access method, and the maximum number of bytes of a database record to store in the root addressable area. The input data comes from the dataset generated during the pointer checking process by the keys out option. The Data Restructure utility allows you to restructure segments and fields to implement changes to the DBD. You can use the Data Restructure utility to change the hierarchy of segments within the database record, delete segments, split a segment into two segments, move data to different portions within a segment, initialize fields with data, unload a subset of the database, and convert a database from one database organization to another. The DBA Toolkit is a suite of useful tools that simplify common DBA tasks. The disassembly tool offers a quick and easy way to produce source code for an IMS control block. You can produce source code for MFS, DBD, PSB, and ACB libraries. This is helpful when you need to rebuild lost source libraries, verify the active source version, or to save, change, or reuse source code. The DBD mapping tool lets you view, print, and export information about the segment structure of a database, including segment hierarchy, internal logical relationships, and secondary properties. The Generate JCL function makes it easy to generate, edit, submit, and store JCL that is optimized for your environment. When you issue a command to generate JCL, the tool evaluates the state of the database to determine optimal JCL parameters and builds the JCL dynamically. The Partitioning and Randomizer Tuning tool is a batch utility that selects HIDAM key ranges or HTM parameters to convert databases into HAL-DBs, and it recommends partition boundaries. You can also use this tool to obtain randomizing parameters for HTM databases. You can use the ISPF interface to view, print, delete, or copy statistical reports, set options at the DBD level in PDX options members, set global default options at the IMS ID level in global options modules, generate JCL to execute the independent pointer checking techniques, access monitoring features, use the database SAP utility to display and update IMS segments and/or blocks, and to access statistical history data. This concludes our overview of Pointer Checker Plus. Thank you for your time. For more information about any BMC mainframe product, please visit the URL shown here.